Innovation, NMIMS University, Shirpur, India. He is also known for his contribution in the voice analytics. He is one of the pioneer of voice analytics for disease screening, and it widely used for COVID-19 screening very recently. He has 5 patents in his credit, and some patents, he's waiting for some patents to get listed with. He is a visiting professor, University of Rome, Italy. He has completed his doctoral Erasmus Mundus fellowship in University of Rome. He is also a recipient of doctoral Erasmus Mundus Strong Ties Fellowship, City University, London. He has coordinated the Mobility of Life project, European Union, in which 12 partners from 8 countries, 212 fellowship, and budget of that project was 20 lakhs euros. He has represented a research group in European Commission, and he is known for his competencies in artificial intelligence, computer vision, machine learning, variable and text in healthcare, startup monitoring, and innovation management. Very recently, he's flashed on ABP Maza for his contribution in the rural India for starting or for some startups in at village level. So I invite Dr. Santosh Bote for his uh, uh, topic on artificial intelligence and machine learning. So over to you, Santosh sir, and hope everyone will enjoy this session. It will really contribute to have a visionary uh, entrepreneur with you all today. So thank you, Santosh sir, for accepting our invitation. So over to you.
Thank you, Murray sir, for a kind introduction.
Santosh sir.
Yeah. Can you hear me now?
Yes, sir, we can hear you.
Okay. So thank you, Murray sir, for the introduction. Another introduction probably which is missing, I think I should give, is Dr. Murray and me was the colleague in a former organization almost for 3 years. So that introduction was missing. Anyway, today I'll talk about machine learning and opportunities to innovate, because the innovation is something which is close to my heart. Let me share the brief overview of the session I'll be taking. The outline of the session is somewhat like this. In first part, I'll cover the general overview of the machine learning. Keeping in mind, there are the programmers, non-programmers, students, faculties. I'll try to keep this session as general as possible without getting into hardcore mathematics and programming, so that every one of you finds it interesting. The second point which I'll cover, there are some ML application which I have developed or my lab members are currently working on. So I'll share how the AI ML can be leveraged to solve the real life problems. The focus of this would be healthcare. If time permits, I'll discuss some application in supply chain and agriculture as well. But primarily, the focus of this ML application would be on healthcare projects. If time permits, in the first half, we'll discuss maybe 5-6 minutes about the various European fellowships and funding opportunities, right from students, undergrad students, to the faculty, postdoc, and beyond that. So in 5-6 minutes, I'll give a overview about that. So students, if there are UG or PG students, they can think of doing internship or master projects or UG projects, or even the complete master degree and PhD degree with those fellowship. So I'll spend few minutes, 5-6 minutes or 5 to 10 minutes onto this topic. This will be your first part of the session. In second part, we'll try to cover some of the cases, some of the applications I'll discuss in the part 1 in a live demo, wherein I'll take one case, let's say voice analytics, and then we'll try to build end-to-end application, and that too, which should suit for everyone here. Like not without any code, how to build the small AI application, because there are frameworks available. You need not to be a computer engineer to build AI ML models, AI ML applications. So that can be built in few minutes. Probably I remember building one AI model in DY Patil, Mumbai in 2006 6 or 7. I don't remember exact year. So we built a model to predict the virulence of the protein. So probably that could have been very useful now if we had translated that into a real life application to predict corona. But we have other models anyway. So it took us around 3 months to build that model. Today, if I want to build the same model, it will take not more than 10 minutes to build that model. So that kind of frameworks are available. That too, without knowing any coding, any programming language. So we can build applications like this. So we'll try to build few applications in today's session. That is second part, wherein you can build or train AI ML models without knowing the programmer, without writing a single line of code. So that's how my session is structured. I hope this is helpful for everyone as to decide when to attend and when to skip. Okay. In a brief, what is AI ML? This we are every now and then it's a lot. We hear a lot about AI ML DL, that is artificial intelligence, machine learning DL. Many times I find people are mostly confused about it. So they don't understand whether AI is same like ML or ML is same like DL, or it's altogether these are the different branches. To clarify that, so I have one slide. The source I forgot to mention, it's taken from the IBM. So artificial intelligence is a broad field. It's not now. It is existed almost more than 50 years from now. Last 15 years, 50 years, we are talking about artificial intelligence. We built a first model way beyond 50 years. So then there are two subsets, particularly we'll be discussing today. The one subset is machine learning. People try to deploy. What is artificial intelligence? Basically mimicking the decision making or intelligent ability, intelligence of the human being, and putting that into some system, some application or some. If you're putting that into a system like a smartphone or the device or the washing machine or the refrigerator, so we call it as a machine learning, because we are trying to make machine learn. So taking a AI algorithm and putting that somewhere into a real life application or devices, and that system learn by itself, then we call it as machine learning. And then if there are multi-layer decision making process, like we need to process first information, and then based on the output of that information, we need to take a next decision. So this kind of application are known as deep learning, wherein we have multiple layers of a learning, multiple layers of a decision making, wherein the decision doesn't happen in a single stage. Like if this is the case, do this or that. So it's not that way. So it is multi-layer. So it's like deep thoughts when we take a decision. That's why it is called deep learning. It's again a subset of a machine learning. So basically for me, all this is artificial intelligence. We are trying to make the devices, systems, application intelligent. So let us discuss why it is gaining a momentum now in a few minutes, maybe a couple of minutes, because I remember using a computer in 2000, and that time I had a floppy disk of 1.44 MB, which costed me around 45 rupees. But now I have few GB of a pen drive or a card, which is costing like 32 GB of a memory card or 64 GB of a memory card, 120, which is way less than what it used to cost me in 2000. So that is the cost of a data, cost of the data storage, and the cost of a data generation. That's me. So do you remember, do you know that when you use a smartphone for 24 hours without making imagine you are not making a single call or not sending a single text, but your phone is just active. In that case, you are making about 2 MB of a data per 24 hours, assuming that you are not doing anything with your smartphone. It's ideal. Okay, you are just keeping it idle and you are doing your routine work. Still, you are generating more than 2 MB of data. So that data talks a lot about you. Imagine the data you are generating in your day-to-day life. For example, when you are updating your Facebook status or WhatsApp status, changing a display picture of the Facebook, if I monitor that for a year, what is your status on the Facebook or WhatsApp or whatever social media you use, and apply some analytics, I can predict a lot many things about you. What kind of food you like, what kind of clothes you wear, what is your preferred brand, which kind of restaurants you would like to dine in. Okay, what are the places you roam in, what is your daily schedule, okay, how is your health. Because nowadays when I have some problem like health issues, instead of going to doctor, many people find it interesting to put it on the Facebook, like having a headache today, or update it on this WhatsApp status. And I don't understand one thing, when the people like it, what it means. It's good that you have a headache, or it's bad that you have headache. I can't interpret that even with my natural intelligence. Forget about an artificial. Anyway, so my point is, the point which I'm trying to make is, we are generating a data, and data is sold for any artificial intelligence, machine learning, or a deep learning application. So I'll be calling it as collectively AI applications. Okay, so unless and until you have a data, probably there is no AI ML applications. Okay, so we are generating tremendous amount of data. Everything is connected. People are having Alexa at their home. Our ACs are smart, our washing machines are smart, lights are smart, fans are smart. So in a way, we are generating a huge amount of data. If I'm using a smart fan or smart washing machine, so it can, if I can connect that to some server and identify what kind of the clothes I wear, what dirtiness of the clothes, and then we can reveal so many things about you. Okay, so there is ample amount of data. Even the data of your e-commerce portal can tell a lot many things about you. What kind of food items you purchase, what are your favorite brands, and that can be leveraged to draw lots of insight. Okay, so data is the soul. The second is, we have algorithm. It has been there quite a long. It's not now. There are no new AI algorithm as such, but you are using existing mathematical and statistical algorithms, statistical tools, techniques to draw the meaningful insight from the data what we get. Okay, so that are what we call AI algorithm. Then the insight which we get is, then the second important aspect is the infrastructure. For example, neural computing. I had a computer in 1999 which was 486, having few megahertz of speed. Probably this neural computing is almost 100 times faster in computation than what the computer or the server I had in 1990, almost 20 years back. Okay, so these are the three things: the data, a storage, and the computation power. To add to this, we are now talking about 5G in India. In other countries, it's already started. That gives us the facility to work globally. So world is local. Even I want to download a few GB of a data, it's a matter of few seconds. Okay, so these are the factors which are helping to create a boom of this, what we called artificial intelligence or machine learning. So these are the factors. Imagine a smartphone, what it can do for you. Just probably we are using it for the communication, but there are many applications. It can talk about your health. It can talk about your personal life. It can have a lot of information about your day-to-day activities. It can do almost many things. So I'll discuss few of the cases today. What the smartphone can do, how we can leverage the smartphone to use its power and leverage its power to make our life simple. I don't know whether we are making it simple or complicated, but let me call it as simple. Now, in general, what is basically the artificial intelligence or the machine learning? In traditional programming, I'm assuming that there are some newbies here. Keeping that in mind, I'm taking this slide. For some, it may be a basic. Okay, so artificial intelligence, I'm comparing with the traditional programming system. In traditional programming system, you define a rule yourself, like if temperature is greater than 25 degree, then turn AC on. Okay, that is a rule. Okay. We pass the rule and then we may pass the data to a system. Data is what is the temperature now. Then the traditional programming system gives us the answer whether to turn off the AC or turn on the air conditioner, or for that matter, whether to take a particular X decision or Y decision, right? So this applies to all the cases in real life. Okay, so in traditional programming, we pass, you need to remember this throughout the presentation because I will be referring to this throughout my presentation. So in traditional programming, we pass rules and data and we get an answer as the output. Okay. But in contrast to this, in machine learning or AI system or intelligence system, we pass answers and a data. So what would be the answer and data? Some answer and data would something look like this. Suppose the situations wherein I have collected a data of last 10 years for the air conditioner. What was the temperature? What was the humidity? What was the status of air conditioner and action I have taken? Okay, so like this, I have collected the lots of data. Okay. Let's say I have 1000 records. So this answer would be my whether I turn the air conditioner on or off. So this is data with answers. This particular fields, the temperature, humidity, and the, let's say user, and the answer is whether I turn the. So this is my data. These 3 columns are my data, and based on this data, these are the answers. Answer is whether I turn the AC on or not. Okay. Now, if I pass this to the machine learning model, the machine learning model tried to build a rule which says that when to turn the air conditioner on and when to turn air conditioner off. And it adapts to the changes. If I update more data, let's say I have 2000 records into a data set, then the rule will change according to the data set. So that's how it adapts to the changing scenario. So it will try to, for example, it will try to identify the scenario. Let's say 0 and 1. 0 indicates off and 1 indicates on. So it will try to identify what was the scenarios using your statistical tools when the air conditioner was turned on. What was the temperature, what was the humidity, and who was the user. Okay, and it will build the logic. If it will generate a rule, if temperature is this much and the user is this and humidity is this, turn on the air conditioner. Okay, so that is how it gives me the rule as an output. Whereas in traditional system, we get answers as output. And in AI system, ML system, we get a rule as output. And this rule keeps on changing depending on the data. That's how it adapts to the situation automatically. Suppose now in winter, there is a different pattern of turning on and off the air conditioner. In summer, it's different pattern. If in Antarctica, it's a different pattern. In India, it's a different pattern. So accordingly, the rule will keep changing depending on the input data it gets. So that's how the ML system adapts to the changes in real life. Okay. So this is how the AI system basic difference between the AI systems and the traditional programming system. I hope everybody is clear with this. Everybody got the fundamentals? Jay, Aditya, Anushka?
Yes, sir.
Very good. Thank you. Okay, now let us move on. Activity, suppose we'll take one example how the traditional system works and how AI system works. Here is an example of activity recognition. The content are taken from the Intel tutorials. So if the space here are 4 cases. Here the walking activity, here running, biking, and here golfing. Now in traditional system, let us say that we have only one measure using smartphone and measuring your speed through Google Map or any utility you have in a smartphone. And if the speed is, let's say, less than 4 km/h, then I can say that it's a walking. But if the speed is not less than 4, it is more than 4 km/h, then I can say that person is running. If the speed is greater than 12 km/h, then I can say that it's biking. But we cannot understand what is this in terms of this rule. Now, how the ML system will solve this problem? What it does, suppose we have 2 sensors mounted in the legs, and it checks the pattern of the movement, and that pattern of the movement will walking is somewhat like this. While running, the pattern becomes something like this. While biking, it becomes something like this, and while golfing, it becomes something like this. Okay. Now, the AI system will check these patterns. The AI system always works on a pattern. Okay. And accordingly, it will label this is walking, this is running, and these patterns are approximate. These are not 100% correct. For example, here, let us take an example of natural intelligence. I'll write something here. Try to read. Probably some of you can read in the first attempt. If
you can read this.
Very good. Now, how this has happened? Had it been accurate, if I type the same thing in MS Word in computer, if I type this in computer, what will happen? It will underline everything with the red line. That means it is misspelled, because it's working on accuracy, precision, accurate things. It's not working on approximation. What brain does, it prepares, it reads the word, then it prepares the rank list of words which are matching those combination of, let's say, F and I. So it will have some words like this. Then in a given case, it prepares the similarity list. In a given case, it prepares the, let us call this as a rank list. What is similarity to of this word being this E for FI in the given situation? It prepares the rank list. The first atom, let's say highest match, let's say 99%. Second atom, 98%. Like this, it creates a rank list. And generally, the first atom is my answer. So that is what we are doing. What it indicates that we are working on patterns, not on a precision. Human brain. Otherwise, we wouldn't have able to adapt to the changing scenarios in a real life. For example, if you have been trained to drive by a driving school and you learn how to take a 90-degree turn, but if there is a turn which is 60 degree or 40 degree or 120 degree, you can easily adapt to that changes. You won't say that, hey, I know how to take only 90-degree turn or cross the speed breaker of 10 millimeter, 10 inches. I don't know how to cross the speed breaker of 6 inches, right? So we adapt to those changes because of this kind of approximation, and this approximation can be achieved by building a pattern of real life scenarios. We build the patterns. So it's not 100% accurate, it approximate. Okay, so otherwise there won't be an adaptation, there won't be a learning. It will be a rule driven system like a robot. If this is the case, do this, but it doesn't work that way. So that is what we need to take from a human brain, concept of approximation, and put that into a machine. And for that, we have various algorithms. For that, various branches of AI. Sometimes we call it supervised learning, sometimes unsupervised learning, reinforcement learning, or anomaly detection, many like this. If the pattern doesn't match with any of this pattern, we call it as anomalous pattern. Okay, if I already known labels, then it's a suitable problem for a supervised learning. If you don't have the labels, then it's suitable problem for unsupervised learning. Let us cover that in a quickly. So building AML model, what it takes to build any AML model. We'll try to take a hands-on session as well, how to build a model from the scratch. First, as I told you, we need a data, and data can be collected through a questionnaires, which is favorite for a statistician. Fortunately, I had all my roommates statistician who are from the PhD statistics background. Then the second thing we can acquire through the sensors. We can acquire the data which is already stored somewhere. So there are many ways. You can use IoT things, you can use smart devices, you can use some sensors, you can use existing data. So there are many ways to gather a data. If you want to have a real-time data, maybe you can use some IoT devices or some sensors. Okay. Then if that data, you feel that there is something missing in that data, I need not to explain to the statistician why we need to do a data pre-processing. We prepare a data, we're missing, cleaning the missing value, adding or removing the noise, or doing the synthetic data, or you enhancing the data. There are many ways you do it. So I'll not talk much about it, assuming that you all are statistician. So pre-processing that data so that it gets into a desired shape and size, whatever we want. Then this data, pre-processed data, we pass to the model. Many times, some people add the model selection step here in between this data pre-processing and model training, because we need to identify which is the right model for my problem, to solve my problem. Depending on the nature of the data, you would select different mathematical or statistical equations to solve the given problem, given data set. So we need to, before that, we need to understand which problem we are trying to solve and how to solve it. Okay, how to map the given input to the desired output. So that is what basically a model selection. Then once we select the model, training the model. What is training model means? Building a logic, like what if we have a regression y equal to mx plus c or b, whatever you call. So building, estimating the values of these variables. Okay. And giving the input x. Estimating value of this slope and intercept. So if I'm talking about, so this is what basically a model training, estimating the values of the variable, then checking how good my model is doing. That is called model evaluation. Like when we teach the student, we take their exam, that's kind of model evaluation, how much they have captured, how much information they have gathered. Okay. So that is model evaluation. If it is not up to the mark, then improving the performance of the model, or even if it is up to the mark, making it more efficient, more effective. So that's a typical machine learning model building process. So collecting the data, pre-processing the data, training the model. Training the model is designing that rule. If you remember my last slide. Okay. So getting this rule is nothing but a training the model. Okay. Then checking how good it's doing and improving it. If it is up to the mark or beyond the benchmark. Okay. Now, how does the artificial intelligence work? So here is a typical classification problem. Let us come to this again. Now, types of machine learning. For me, generally people have many branches, but I broadly divide it only in 3. But sometimes people say that the reinforcement learning is a separate branch. So I have added the 4 branches here. For me, it's only 3 branches: that's supervised, unsupervised, and anomaly detection. But in books or in many references, you will find there are 4 branches. And people have come up with the many other sub branches of this, but will not go into that detail. I'll quickly explain. What is anomaly? It's something like an outlier for the statistician. So it's anomalous, it's different. Suppose now everybody, assuming that everybody is listening to me and looking at my presentation, if somebody started dancing, singing loudly, we'll call it as anomalous behavior. It's normal, different than a normal. It's anomalous to the what exists usually. Okay, so that is what we call anomaly detection. So this kind of programs can be used very well for various real life application. For example, finding the customer. Suppose we have a data of the customer who have repaid the loan, and we want to find out who is going to make a default. The characteristic of the customer which doesn't match with or are not similar with my existing data set, we'll call it as anomalous, and that person may be a defaulted customer. Or engine noise and vibration in aircraft or any machine or any vehicle, the normal pattern of vibration and noise, if it is not normal, Bosch is earning a millions of dollars, rather billions of dollars by just developing one tool called anomalous behavior monitoring of engines. They identify, record the noise and vibration of the bearings of the any engine on the shop floor in an industry, and they detect what are the normal pattern and what are the abnormal pattern. What are the pattern when they get the bearing damage in early stage. In moving parts, the bearings are the very important component, and that causes the maintenance, that the breakdown of the machine. So they have stethoscope kind of things which records the noise and vibration of the engine, and they identify what are the anomalous pattern, and that the machine they do a maintenance. So they can do a predictive maintenance through anomaly detection. So anomalous pattern of the engine noise and vibration. So like this, it can be used for various purpose in real life. Then supervised learning. The supervised learning, as the name indicates, we have a supervisor which tells us. This is not a physical supervisor. The supervisor is a label of the data. Suppose I have a data like this. Let's say, take an example from education domain. Important is result and the student number of classes attended, the last year's question paper referred, last year question paper, and books referred. Okay, based on this we want to predict the result. If I have a result, let's say pass, fail, or a grade, or whatever system, depending on the, let's say, A, B, C, D grades. Now if this, I consider this label, this answer here in this case is result, the grade secured by the student. So I can identify easily what are the things that I need to do to score the grade A or grade B or so on, right? So as if this label is guiding me to do, refer this book, refer these many question papers, and attend only these many classes. Okay, so this label acts as a supervisor. It tells me what is to be done to achieve the given result, given target. Okay, so that is why we call it as supervised learning, because this label act as a supervisor. If I remove this column, label column, from the data set, then it's difficult to predict what is common. Then what do? We identify what is the similarity between this field. So the supervised learning is a typical problem of classification. Okay, in statistically, you know classification better than me, I hope. Okay, then if I don't have a label, then it is a suitable problem for unsupervised learning, because there is no one to tell us what is to be done to achieve the grade A or secure the grade B or so on, right? So the supervisor is absent. That's why it is called unsupervised learning. In that case, we group the data based on the similarity. So number of hours, number of classes attended, based on the similarity, we group them, and this problem is suitable for clustering and is known as unsupervised learning. And the reinforcement learning. I hope everybody got a punishment during the school or a college. I remember write this 100 times, okay, to improve my accuracy. If I made a mistake in some mathematical calculation or some grammar or something, so the teacher used to tell me, do this 100 times. Probably this must have happened to you as well, many times, all of us present here today. Okay, so this is kind of reinforcement learning. We are practicing a particular game to improve is reinforcement learning. Doing the same thing, learning from the mistakes and improving upon it is a kind of reinforcement learning. So these are the 4 categories of machine learning. Now, how does the supervised learning works? So supervised learning works, takes the raw data as an input. So what would be a data here in this case? Color of the fruit, size of the fruit, let's say weight of the fruit. Okay, these are the parameters, or depending on the type of data, measurement techniques you have, whether you have a sensor, whether you have weighing balance, whether your any IoT device to extract the parameter. So what it takes input data. That input data may be in terms of parameters, and the parameter has a label. So this is apple, this is peach, or this is the mango, something like that. So we know what is mango. How does the mango look like? The mango is yellow in a color. Shape is like the oval shape or whatever shape it has. Then the weight, average weight. Now, if these are the three parameters: color, size, and weight, based on which we can differentiate a mango, apple, and the peach, right? So we know in terms of this parameter what is apple. We know in terms of this parameter what is mango. We know in terms of these parameters what is other fruit, right? So like this label help us whether it is apple or orange or the mango or any other fruit, and the label act as a supervisor. What is to be called mango, what is to be called the apple, and so on. Okay, so we train the model to understand what are the common thing when the fruit was called apple or the mango. Okay, and then it builds the logic. If the color is red, this weight is average 150 grams, the shape is round, then it's apple. So this is the logic which it will build through this training process. Okay, so now then we'll get the three rules. If it is orange, then the mango or apple or the mango, whatever it is, right? So we'll get a logic. If this is the case, then it is the orange. If we update more foods, we'll retrain the model and the rule will get modified automatically. Okay, so that is what supervised learning is. Having, let's say, the data something like this: weight of the fruit, then color of the fruit, size of the fruit, and last we have name of the fruit. If I have this data, the name acts as a supervisor and we can build rules to identify the different fruits. So that's what is basically supervised learning. I hope it's clear to everyone.
Yes, sir.
Veer, Kunika, Mansi. I hope
Yes,
you are
sir.
listening.
Yes, sir.
Okay, very. So this is what
Yes, sir.
basically supervised learning. Now, unsupervised learning. Unsupervised learning, as the name indicates, we don't have the supervisor. What is supervisor? The label column. Then what we do, we find a similarity of objects and accordingly we group them together, and these groups are known as clusters. You know clusters very well. So I'll skip explanation of the cluster. So we'll group them into a different category. Again, we'll measure the similar parameters, let's say weight, color, and shape of the object. If the weight is similar, then we'll compare the color. If color is simple, then we'll compare the shape. If the shape is similar, then we'll put that into a particular category. Okay, so that similarity doesn't mean exact match. It is approximation. Okay, the color is approximately same, the weight is approximately same, the shape is approximately same, because sometime we may have an apple which is not completely round. Okay, so that's why it is approximate. So it groups them into a category, and then these categories can be labeled, or we can identify this category 1, category 2, cluster 1, cluster 2, and so on. Okay, so that help us to now what is the real life application? Suppose we have a customer database here. Customer who have purchased different items. Okay, now now we have collected the data of this customer, like the items they buy for last 10 years. Let's say for Amazon, we will have billions of records. We get a new customer, the customer will have the same characteristic, like his age, location, where he stays, a salary, and items he purchased. Okay, now this age group staying at this location, having this salary, can purchase which item. So we'll have a list of items purchased by those customers. So we can identify to which group this customer belongs to. So we can predict a new customer, what is most likely the purchase is going to make. We may have data, the customer will have purchased only when there was an offer. So we can predict using this unsupervised learning whether the customer is going to purchase the item or not without an offer. If he is not going to purchase, what is the offer we should give so that he can purchase? Okay. So in 2013 or 14, I think we built a model for Maruti car showroom in Nerul, Navi Mumbai, to identify the customer preference through the game. So we asked the customer to drive the different kinds of vehicle in the virtual simulated environment, and then you identifies purchase preferences and accordingly recommended him or her a car. Okay, so this is buying behavior prediction can be done with the help of this. So it can be applied into many real life applications. Suppose you have images, let's say tissue images or the biopsy images, and whether it is having a normal pathology or it is having some disease, we can compare. So, right. So there are various applications of this unsupervised learning. Now, as I told you, supervised learning is a typical classification problem and it requires a label data. Clustering is unsupervised learning is a clustering problem, and when we have unlabeled data, we use clustering techniques. So like we can use regression. I think you already studied the regression yesterday, so I won't go much into details of this. And supervised learning can be executed in control environment, and in unsupervised learning, it is a less control environment. So this is a theoretical things about supervised and unsupervised learning. I hope it's clear to everyone. The next is anomaly detection. Like I said, if somebody started singing loudly here or dancing in the classroom instead of listening to the teacher, so we'll call it as anomalous behavior, and probably we'll find a mental hospital nearby and put him or her into that hospital. Okay, because the person is showing anomalous behavior. So this anomalous behavior not always a bad, like singing, dancing class. The anomalous behavior can be used to predict various things. For example, which I shared with you, the engine fault, the detecting the noise and vibration, change in noise and vibration pattern in early stage, so that we can control the induced damage due to the failure of the bearings. Or we can detect the cracks in the airplane wings well in advance through the noise and vibrations. Probably you know the noise and vibration is different when you are, let's say, consider empty box. When you tap it, it has a different noise and vibration. When you fill it with something, it has a different noise and vibrations. When it is half filled, again there is a different noise and vibrations. Okay, so you can use it with your smartphone. Smartphone has a vibration sensors. It has the movement sensor, which is very accurate in the order of millimeter, which can be used to sense the vibrations. So you can check the road conditions, put a smartphone into a vehicle, that kind of vibrations you are getting. Based on that, you can check the road condition, you can check the engine health, you can check your driving patterns. So you can predict the possibility of person making an accident. We can have a model trained to detect the normal driving patterns. If it is not matching to that, it's anomalous or accident prone driving patterns. Okay, so just record the angle, speed, and the angle, velocity, and driving pattern of the user. Or you can take, let's say, we have few levers to control the vehicle, that is clutch, accelerator, gear, brake, and steering wheel. Okay, now record the data of this and label it, whether it is normal, what driving pattern, what kind of driving pattern it is, whether it's normal, risky, fast, slow, whatever pattern you are using. Okay, so this kind of patterns we can build. We can build this kind of pattern, and these patterns can help us to detect whether the person is showing a normal behavior with which exists in our database, or it is a risky driving pattern, anomalous behavior. Excuse me for a moment. Give me a minute, I'll be back. Okay, so like this, anomaly detection can be used for various real life applications. There are limitless applications. There's not a single which I can mention here. So there are almost application in all the domains where we can use this anomaly detection. But for that matter, any of this algorithm. Now, what kind of algorithm you should use, it depends on the data. What kind of data you have, what is the tendency of the data, and how it is scattered, how it is distributed. So based on which we can detect which model would be most suitable. Okay, and you statisticians are very well comfortable with identifying what kind of data you have. We have various techniques to understand. We have various values, p value, c value, confidence interval, f value, right? So that tells you the kind of data you have, and based on which you can choose which model you should use. So this is all about anomaly detection. Now, so anomaly detection is based on finding the observation or the record which greatly deviates from other observation. Okay. Now it can be used in telecom, it can be used for detect roaming abuse, or in banking to detect the fraud or cyber crimes, financial and insurance, in healthcare, manufacturing, video surveillance. Like in video surveillance, you can detect the normal behavior or identifying a thief or identifying some suppose we have mounted all the video CCTV surveillance all across the city, and we want to detect the anomalous pattern like the riots or people damaging the property, public property. Okay, so normal movement behavior will record, and if there that is not matching any movement, then we can detect that there is some, we can raise an alert. Okay, so anomaly detection can be used in various applications. Reinforcement learning, I already talked about it. Like we have a reward and punishment mechanism. Through this reward and punishment mechanism, we identify what is to be rewarded. The rewarded means we enhance its weight, and it plays major role in a decision making or a prediction. Okay, next decision. So the reinforcement learning and practicing the particular game or repeating something and learning from the mistake is nothing but a reinforcement learning. So agent makes action and checks the environment with respect to the parameter, and the agent is rewarded either positive or negative. Negative reward means the weight has to be reduced. The positive rewards means the weight of the particular action has to be increased. Okay, that means you have done it correctly. Okay, so that is what basically a reinforcement learning. So these are the 4 categories of AI/ML models we use: the supervised, unsupervised, reinforcement learning, and anomaly detection. I hope it's clear to everyone, all the 4 categories. Wasim, Vishaka, Snehal.
Yes, sir.
Yes, sir.
Very good. So I thought I am alone speaking, but thank you. You all are there. Now,
Yes, sir. Yes, sir.
why this ML is needed? Earlier, we had like the approach, reactive approach. When something happens, then perform some action. Then we thought of being proactive with the advent of computers, and then, but now even the proactive approach is not suitable. We need something which is predictive. Everybody wants to predict. I want to predict what is the books to be referred to achieve a particular score. Parents want to predict what is the average salary that my son or daughter will get. The doctors want to predict what is the possibility of person getting a particular disease. He wants to predict what is the right dose of a medicine to be given to the particular patient so that I can cure that patient. The supply chain manager wants to predict what time my truck or my vehicle will reach to a destination. Okay. So the pizza delivery boy wants to predict what will be the total number of orders today I'll get, so that I can schedule my activities. Ola wants to predict where I will get more customers in a particular time, particular region. Okay. So how many taxis I should be deployed into that particular region. So the entire world is becoming predictive. Amazon wants to predict what are the atoms that will customer will purchase together. So it's all about predicting the things. Now the reactive and proactive approach are no more valid in businesses. No matter which business you are doing, in each and every business, even the restaurant owners want to predict that how many customers will be there on the restaurant, how many people I want to depute onto a kitchen, or the waiters, or the cleaning the, or how much raw material I would need so that I can cook the good quality of dishes. Okay, so the prediction is required almost in all the domains of the life, no matter which domain, which branch you are studying, irrespective of the age, gender, country, or the location. I think we want to predict. The things are now no more reactive or proactive, they are predictive. So to satisfy this prediction, why it is possible, as I told you earlier, it is possible because we get a data every now and then. It is because of the high computation power available in your pocket today in the form of smartphone or the devices, smart devices, the sensor devices giving you the data, and the processing power. Running AI model, I remember we had the Onyx server in one of my previous organization, which is costing few lakhs, around 50 lakhs, and processing a few GB of data in 3 days. But I can process that data in a few minutes now. Okay, so everything has become due to this technology, the connectivity, 5G connectivity, the computation power, the storage, and the bandwidth which we have, or connected bandwidth we have, that made everything predictive. So that's why we need ML, because for a doctors to remember all the patterns of the patient is not possible. Which medicine was given to this patient and what was his results, and how many days he or she took to recover, whether he has fully recovered. Remembering all the statistics at one go, or identifying that doctor gets hardly 5 minutes to see a patient, but saying all these records in 5 minutes not possible. Probably he needs AI. So likewise, for every field, the farmers need AI to understand how much he or she should irrigate her or his crop to get a particular yield. What should be the different fertilizer quality and quantity of the fertilizer should be used. What is the insecticide to be used to kill the insects, the proportion of the insecticide or pesticide to be used, right? So all this field are becoming predictive. That's why we need AI ML. Even the students want to predict how much score I should get. So minimum number of units I should study so that I can score this particular grade. And the number of question papers, I'm not intentionally referring to the classes to be attended. Okay. Now, let us discuss few cases which we have done or partially implemented here in healthcare domain. Okay. How the AI ML can help us to overcome the various challenges in AI domain. Okay, give me a moment. Okay, so let us discuss the few cases. Let me show you a small video clip of one of my startup by Marco from Germany, the project called ADA. Okay, so I hope I'll be able to play the clip. I hope everybody can hear. One example of supervised learning. Your statistics. So the next version of this, they are in 2014 or 15, I don't remember exact year, 15 or 16, they have collaborated with Amazon Alexa, and look at the wonderful application they have came up with. I hope you all can hear the sound.
Yes, sir.
Okay.
Yes,
Hi,
sir.
I'm Sophie. I'm a mother of two, and I've been using Ada for several months. Ada is a very helpful personal health companion. When I'm at home, I usually use Ada via the Amazon Alexa. It allows me to get answers simply by talking to Alexa without even taking out my phone. Alexa, open Ada.
Hi, I am Ada. I can help if you're feeling unwell. Please name the symptom that's troubling you the most.
I've been having dizzy spells.
Okay, dizziness. How long has this been troubling you?
A few days.
Less than 1 week. How does making sudden head movements affect your dizziness?
It gets worse.
Okay, worsens. Are you having difficulty keeping your balance?
Yes,
Do you have nausea?
yes,
Does your ear feel full?
no,
Do you have reduced, distorted, or blurred vision?
no,
Do you hear a buzzing, humming, or ringing sound in your ear?
no.
Thank you. I'm now ready to create your report. 6 out of 10 people with these symptoms have benign paroxysmal positional vertigo. It might require medical attention. If you wish to, you can send this assessment along with a question and receive free advice from one of our Ada doctors. Would you like to do that?
Yes, please.
Okay, that's done. One of our doctors will be in touch soon. Bye for now, and get well soon.
Thank you, Ada.
So the milestones of the Ada, we started in 2011 at University of Rome, and then in 2018 it has this many users and this many symptoms. Okay, so it has grown tremendously. So the data can help us, and last year it was last year it was awarded as the fastest growing startup of Europe. Okay, so I see a lot of application of all the techniques we have seen. I have seen supervised learning, I have seen classification, clustering, and anomaly detection. In all these cases, even the natural language processing. That's another branch of AI/ML, but it's implemented using one or other technique we have studied. So this is kind of application we are going to build. So ultimately, it's all, as I told you, is building, identifying the patterns of the data. To build up approximation, we build the patterns of the parameters we measure. Whatever parameters we record, whatever features we extract out of the given situation, we build a pattern and we compare those patterns, whether it's similar to some existing pattern into our database or not. Okay, and that's what basically a machine learning is in a abstract form. This is what a machine learning. Now, how the human, let us understand how does the human brain builds a pattern. Okay, and can we transport those patterns into a machine, that pattern building process into a machine? So let us have a descriptive view. The human has a brain, probably everybody has a single brain, and they have only 5 senses. Nobody here probably have a 6th sense, that is logical calculations. There are no 6 measurement techniques. The touch, vision, listening, taste, and smell. These are the 5 senses everybody has. Now, all these 5 senses can make you a doctor, you can make you a lawyer, engineer, or driver, the cook, the artist, the actor, anything can be made out of this 5 sensor and 1 brain. Okay, I hope everybody agrees to me on this. So let us talk about the doctors. Okay, doctor also have the same 5 number of senses. What he does, he measures some parameters. These are under investigation. This is one of my patent. How many parameters we measure out of the situation using 5 senses. In my opinion, we measure only 117 parameters. Okay, for vision. So I have 2 numbers here. I'll explain you in a while what. So vision, smell, taste, touch, hearing. Then we have a complex parameters, complex thing, something called grammar. So the parameters are divided into 2 parts. One are measure. One factor is measure parameters. That is called this MP. And the second is scaling parameters. Okay. Now, what is measure? When I see something, I measure color, weight, shape. These are the measured parameters. What is scaling parameters? Suppose your friend is standing below the tree and some big fruit is falling from the tree and like aiming at his head. So will you tell him, hey, there is a weight of 9 kg coming towards your head at 9.8 meter per second, or simply will say, hey, baaju mein hat ja. When you hear the noise of braking, based on the intensity, whether you will look at the vehicle first and then move out, or first move out and look at the vehicle. So that is what basically are scaling parameters, which decide the scale of a reaction at the given moment. Okay, and whatever we measure, these are the actual sensory parameters, what we sense out of the given situation. We want to bring the same mechanism into a machine learning, and then it is subjected to the grammar of the situation. Like, what is the grammar of the situation? Suppose you are hungry or thirsty, you are studying very hard, and your mom is there, and you will ask, hey mom, please give me water or give me something to eat. Now, if I miss the grammar, who is your mom? Wife of your father. So instead of saying, hey mom, please give me a water, I'll say, hey wife of my father, please give me a water. So instead of water, you will get a tight slap, right? So that's what the grammar is. How to use, how to interpret the sense and scale parameter in a given situation. Okay, so that's what basically the intelligence. It's a kind of decision making, and this all together it creates a pattern, and this pattern we called a knowledge base. Like, everybody has their own knowledge base. Now we build a pattern out of these variables, and we compare that pattern into our existing database. That database is called knowledge base, out of which we build a case specific database. For example, if you listen to my previous example, if you can read this, so all the collection of all the words is my knowledge base. My case specific database is words made up out of F and I, or Y, U and O. So it will list out me all the words which is made up of these 3 letters. So Y, U, O, Y, O, U. Like this, it will list out me all that is my case specific database. And after that, I'll prepare the rank list, which is my answer. So that is how the decision making happens. So that is what the intelligence, and that is what we are trying to bring into machine learning. So these are the measured, scaling and grammar parameters. Okay, now let us check out the possibility. So out of all this, we build a pattern. Let us take one simple mathematics, like weighted average. If it crosses the threshold, then it's a particular decision. If not, it's not that particular decision. Okay, so that's how we calculate the inputs. These are my measured parameters. Weight are my sense scaled parameters, and this is my situation grammar together with this threshold. Okay, so as simple as that. Okay, I hope everybody understood this concept, that we have input parameters, then we have scaling parameters, then we have grammar parameters, which gives me the particular decision as output, particular rule as output. That's how the AI system works. Okay. Now, let us make it a little more complex. When we have multiple parameters and multiple weights and multiple outcomes out of this, we use these complex mathematics. I'll not go into much detail, but just give the overview. Hidden layer develops the patterns and perform the pattern matching. And this pattern, if matches to alpha or beta, accordingly it predicts the outcome. Okay, so these are the simple calculation. I think being a student of statistics, you might be knowing some of the calculation. So this is the kind of back propagation where we modify the weights of the layer so that it improves on the performance, some kind of reinforcement learning, you can say. Then we compare what is actual output and what is a target output and actual output. The difference is multiplied with the error. Okay, and we calculate the weights based on the error and modify. For example, consider a situation you wanted to make a goal in a football, in a goal post. Then you kick the ball, but unfortunately it just passed the goalpost, not within the goal. So you calculate what went wrong, whether the angle of kicking, the force you applied, or the wind speed, what went wrong. Then reducing the importance of that, that is what basically we adjust the weight. The factor which went wrong, we correct it and then redo it so that if you can make the goal inside the goal post. So that applies to any real life decision. It may be your prediction, it may be your disease diagnosis, it may be cooking a particular dish, it may be fighting a case in a court, it may be teaching something, it may be writing in exam. So predicting something in all the cases, right? So there are some interesting questions here, which will probably beyond the scope of today's session, but still I'll pose those questions. You try to find answers, and if you sum up, you get some answer. There is no right and wrong answer to this, but if you get the answer, why it is the case that when we start writing the exam, we remember very few answers, but at the end of the exam, everybody of you become like a superhuman and you try to recollect some or something about all the questions. Okay, so why that happens? The second question, we'll discuss that some other time, or you can contact me via email. Second question, the dreams which you see while sleeping are color or black and white. If color, how and why? If black and white, how and why? Try to answer these two questions. Probably you'll understand a lot of things about machine learning, what we need to do. Okay. So this mathematical aspects I'll skip. Now, if I want to compare, this is what basically artificial intelligence and the natural intelligence. Natural intelligence is, if you look at this picture, sensing the parameter from the situation, scaling those parameters, and then finding the similarity of those parameters into your knowledge base, in whatever data you are in your brain. Now, with this sense, if I have to compare this with the machine, artificial intelligence and natural intelligence, suppose I replace all your natural sensor with the artificial sensors, like a touchpad. If I touch a mouse pad and draw a particular line, it measures exact distance in millimeter. If I draw a line on your skin, will you able to measure with the same precision? If I see a particular image, will you able to recognize as many as object which the camera can recognize through your eyes? Probably no. The voice, I am working in the voice diagnosis, as Dr. Mule has said, that we record 1 lakh data points per second and we build a pattern out of it. Probably those many data patterns we cannot identify. My mic can identify a separate pattern, separate frequency. There are 100 people speaking together. I can record the one which I want. Okay, this is not possible for the ear. Similarly, for taste and smell. The example of taste and smell is the smoke detectors. Probably not everybody can sense all the molecules, but it's presence of single molecule. Okay, so if I replace this, that means my brain will get more accurate data. I have enough storage nowadays. Like if I put a server rack, it can store millions of GBs of data. So, and I have computation power to process that as well. Now, if I measure everything in a real life with so much precision, will my decision be precise? Obviously, yes. So that is what we need for artificial intelligence. Nowadays, we are going ahead with the regular parameters, what we measure out of the situation, but we need to go in this way. Okay, this would be a architecture for general intelligence. Okay, the same machine will able to predict the disease, same machine will able to predict the customer, same machine will able to drive the airplane, same machine will drive the car. Okay, so to reach to this level, we need something like this, the architecture which is best or inspired by human brain, because human brain can be trained into anything else like this. Brain can be trained to be a doctor, a lawyer, a pilot, a driver, a cleaner, a cook, artist, anything, right? So this is what we need in AI now, AI ML now. Okay, and I think it's possible, but it will take its own time. It's not today. We are lagging in some algorithms. We are lagging in some equations. There is a lot of scope. So if I want to be a physician, who is going to be a good physician? Definitely a computer, because it can measure many things precisely, more precisely than a doctor. Like you are seeing the example of Ada. Okay. So ultimately intelligence result into some or other kind of decision making. So the computer will be a better decision maker compared to human brain. So let us not debate this at this point of time, but here are the few examples which we have developed. This is a clinical decision making process. I have a group of doctors. I posted one image of simple X-ray, and all are expert doctors in diagnosing X-ray. Still, I have different opinions. One says that it's a fracture, one says it's a displacement, it's a ligament tear. All are expert doctors, but and they have something to justify. They say 10 equally right decisions. How it could be, but they are in medical term, they have something called 10 equally right decision. But as a AI expert, as a ML expert, or as a scientist in this domain, my or your expectation should be a single best decision. What is the right medication, right dose to be given to the patient so that he will be recovered in 10 days? Okay, so definite answers, not 10 equally. ये 10 दिन लेके देखो, बाद में देखेंगे change करना है कि नहीं. So this is called 10 equally right decision. But with the advent of AI and these technologies, we can come out with the single best decision. In line with this, we have done some of the case studies. I quickly present that. I know it's time for break. So next few minutes, I will try to present some of my projects in AI/ML. So being healthy is a combination of various things. So I'll just run through this. What is basically a diagnosis and treatment is a correlation and regression of a different patterns and a continuous learning. I hope now you can understand this statement based on all our previous slide. Now, the pattern, this image I have taken 10 years back. Fortunately or unfortunately, I don't know, this resembles to corona, but anyway. So identifying these patterns of the organism, patterns of the symptoms, patterns of the various imaging we do in the clinical, and correlating them with the pre-existing conditions or various health conditions. That's what a basically diagnosis. Let us consider the simple example, the ECG. We have developed a sensor which can measure. In modern medicine, they measure PQRST. There's many points only, but we measure 1,000 data points per second, and we build pattern out of this. Definitely is more precise, and it can detect the cardiac problem in early stage, not when it appears into your ECG. Well before it starts troubling your heart or it starts troubling your body. Okay, we can detect those patterns, the cardiac blockage, almost 2 months in advance, because there is change in pattern. So that pattern AI can detect with very high accuracy. Another project we are working on, we record the pulse 3,000 times in a second. The Ayurveda is known for understanding 72,000 pulses. These are basically patterns. Like the pulse moves like a snake. Here you can see the pattern of the snake. Jumps like a frog and swims like Hans. These are the pattern. Okay. So now each of these pattern, if you record these parameters, gati, rate, rhythm, force, tension, temperature, consistency. Okay. So, all this pattern can give me in 3,000 readings per second, can tell me even what kind of food you had or whether there is some disease in your body. Okay. So this is a pattern building through these sensors. We have developed a sensor. So far, we could establish only 3,600 patterns. Now ECG, we have almost 600 plus patterns, which indicates various cardiac health conditions. The optical measurement system, we have developed a system using which we can record the pixels. Suppose, let me show you the regions we are targeting through image processing. If there are more than 33% blue pixel in this particular region, that indicates that cardiac blockage. If the number of yellow pixel in this region and the forehead are more than 18%, then it's a jaundice. Okay. So this is what the machine learning can do, objectively looking at the things what you can measure. Instead of subjectively going jaundice detect karne ke liye, you have to have a blood test, then detect the bilirubin percentage, on the basis of which you will detect whether the person is having jaundice or not. Instead, if it affects the signal which I can measure, whether it affects my walking pattern, whether it affects my speaking pattern, whether it affects my spatial structure or the color concentration of the various pixels on my face, right? So then we can diagnose. Then voice project. So voice is, we have now patent for almost 17 disease confirmed, and we are evaluating another 72 diseases including corona. It started in NESCO, now Mumbai, as well as MIT USA, IIS Bangalore, and some in some hospitals abroad as well. So we started detecting the pattern of the voice, speaking voice, in terms of these parameters. There are 6,000 plus parameters which we can record, and each parameters are recorded when we speak. The voice, the airflow is incident on these 18 points, which we call point of articulation, and it builds me, give me a particular pattern, and this pattern gives me the COVID infection pattern. Okay, we are built. In afternoon session, we'll see one case hands-on session to detect COVID using voice analytics. How to build. Okay, so Sika, I'm just coming to the end. Give me 5 minutes more, then I'll take questions. Then Parkinson disease, through voice, we have built a pattern. The cardiac coronary artery disease, this is a normal voice pattern, and at the bottom, and this is a cardiac issue, particularly blockage. This is for a tuberculosis. These are the patterns, the parameters we measure. This is healthy people range, and this is for a tuberculosis. Like this, using AIML, we can detect those patterns. And at University of Rome, we started it is larger level. You can visit them. Okay, so we can do a telemedicine, remote diagnosis, and many more projects with this. Okay. Similarly, we can analyze the motor movement, walking pattern. Probably you might be knowing when you are depressed, your walking style is different. When you are sad, your walking style. When you are happy, you are hungry. When you are thirsty, you are taking it to the next level, and we are detecting the diagnosing of some diseases by analyzing the motor movement. And you can just visit this website, captix.com, for more details. Okay, so currently we are using it for the sports application, the motor movement analytics. The motor movement analytics can be used in industrial shop floor, when I can identify the movement of the particular person and the reason for the low or high productivity, and accordingly I can plan the personalized training for him or her. Okay, like this motor movement can be used. There are many applications which you have built in healthcare through the objective monitoring of the various biosignals which we can measure. So don't go with the subjective or thumb rule to detect the disease. You need to measure this. No, measure whatever you can and identify the pattern in case the person is healthy and unhealthy in those data points. Okay, simply the typing pattern, the way you type can reveal so many things about you. When you are stressed, you make some common mistakes. When you are having cardiac issue, there your motor movement gets affected a lot. Okay, this particular keystrokes will be mixed. So you can design a text to type and ask the person to take a typing test at sitting at home, and you can diagnose many things, whether he's depressed, whether he's willing to come to the college today or report to the office today, how is his performance, how is his attention today. All these patterns can be simply measured. So just look at the things objectively, not subjectively. So instead of how we can measure, focus on what we can measure and build a pattern out of it. Okay, so like this, we can build a pattern of various signals, and then it can help you with the various real life application, maybe a diagnosis, maybe industrial application. The AI has, the Intel has built this AI cancer screening. It is more accurate than a doctor. It identifies the image in early stage and detects whether it is skin cancer or not. The doctors need to carry out the biopsy test to confirm, but this device confirms it within a few minutes at the OPD only. Okay, so like this, objectively we can look at the things and collect the data and build a pattern out of this. Okay. So this is all which I wanted to share. This objective monitoring can build. Now we need to couple this with the money earning objective. All Indians are scientists by birth. We need not to be a scientist. Let me prove that in a couple of minutes, then I'll stop. So we forget to link all our activities with earning money. That's why we are not successful scientists, what I believe. Okay, these are my personal opinion. Why I think I am, we all are scientists. Everybody looks at this picture as a crowd. These are common slide I use in all my presentation, but I look at this picture as the best example of patience. Attending the class like today, even if you are not interested, I think it's the best example of patience. Attending six classes a day, it's the best example of patience. That's what we need for being successful. The skill, maybe the Michael Schumacher drives the best car equipped with the best technology, but this farmer has the car with a zero technology. Still, he manages to reach safely even the vehicle is overloaded in the Indian road conditions. Okay, so he has a better skill. With this picture, you will agree that you all have the skills, but you are only using it at the wrong location. Like how to convince a teacher, you have intelligence for not submitting assignment. Jo dadaji nahi the guzar gaye. How to make a face, what kind of expression you should have, what should be the words you should use to a particular teacher. So all this requires a lot of skill than program building AI ML model. So we have a skill, we have a patience, we have everything, but what stops us being a ML enthusiast is this approach. Okay, that's all from my side. Thank you very much. If you are interested, we can share a few things about the fellowship in a couple of minutes. Thank you.
So can we take a few questions?
Yes, sir, please.
Yeah, I request students to post a question in the chat box also. There's one question which is talking about how much mathematics is needed for AI, machine learning, and DL. And in addition, the person has written that she is Shikha Maheshwari. She has written any mathematician with a basic knowledge of statistics can become a data scientist, and a question mark. So can you put a light on this?
Yeah, sure.
Basic question is how much mathematics is needed for AI, ML, and DL?
I think the mathematics knowledge, what you like is let me give an analogy to a real life. Suppose you want to learn a driving. Do you really need to understand what is the cylinder size, what is the capacity of engine? So capacity of engine is a mathematics. But when and how to use that, if you want to enhance the capacity, just press the accelerator. So that much is introductory knowledge. You need to be a driver. You are not a mathematician here. You are not going to devise that. But only thing you need to know is when to use what, which mathematical model or which statistical model is suitable for my data. Applied knowledge, not necessary you should know all the in-depth knowledge of that. Only applied knowledge is required in my opinion. The second question was, I think, any mathematician with basic knowledge can, yes, obviously, as I answered your second question as well. Anybody with the basic knowledge of mathematics and statistics can become a data scientist. It's all about knowing your data and understanding which tool to be applied on that data. I think anybody without the knowledge of hardcore mathematics and statistics can do this.
There's one more question. The question says that which courses are required to learn artificial AI and ML?
Okay, so there are courses. If you are comfortable with programming, then there is a free course from Google. I think nobody can teach better than Google about AI ML. If you search in Google AI ML tutorials, you will find that there are free courses along with the certification. They give you a free certificate as well. You can do that course. Another course which I'll probably try to give the link in the afternoon session from Microsoft. Another is NVIDIA. These are the free courses I am telling you. NVIDIA, that's a company which is very strong in graphics processing. And the last one is IBM tutorials. These are the free courses. Beside this, you have many courses by many providers you can do. And if you are not interested in video tutorials, you are just content-based tutorial, you can visit machinelearningmastery.com. There you will learn about the fundamental of mathematics and statistics as well as the machine learning. But it requires some programming skill. If you're not interested in programming, you should focus on NVIDIA or Microsoft Azure Studio, ML Studio. So there are courses for non-programmer, particularly Microsoft, NVIDIA, and for programmers, Google and IBM. So I think choice is yours, whether you want to go as a programmer or a non-programmer. For both, there are options. As I think Shika, I already answered. If you are using studios, the frameworks, depending on the application you are trying to build, you can build AI/ML model, which I'll try to demonstrate in afternoon session without writing a single line of code. But if there are some very niche areas for which we don't have pre-existing algorithms, you are developing a new algorithm, probably in that case, you need to have some knowledge of coding. The language which is quite popular in AI/ML community is Python. So if you understand the fundamentals of Python programming, probably you can use both the frameworks, the non-programming as programming framework as well.
I think you already answered the another question which is raised by Shikha, that is how much programming knowledge
Yes.
is required. There's one more question by Uma Maheshwari. She says that what are the tools required to learn for data scientists?
There are many. There are very difficult to name all the tools, but the few of the important tools are like ML Azure Studio or Amazon AWS or Google GCP platform, Microsoft ML Cloud. So these are the tools which are Google BigQueries. These are the tools, or rather not a tools, complete frameworks. And mostly they are programmed in Python R. Or you can use your statistical tool as well, like SPSS, SAS. These are the tools using which you can do a lot of data analytics. So you can choose any tool. There are no comparison as such because ultimately the base algorithm they are using are the same. Only thing, the user comfort. If you are a programmer and if you are non-programmer, depending on that, you can segregate the tools. I hope I answered the question.
Yeah. Thank you, sir. It was a very nice session. There is one more question which was and he is asking about which programming language prefer lab Python.
It really depends on the situation. If you ask this question personally to me, I will always prefer Python due to various other features like the portability, the lightweightness, many other factors, the open source. So I'll prefer Python. But if there is specific case which is suitable for the MATLAB, so these are the tools. I think they are, we cannot compare this tool because they have their own advantages and limitation. Using this tool, you can build your applications. That's the only thing common in all these tools. Any tool can be used to build any application, but at the end, what matters is the resources it takes and the output it produces, whether it is acceptable to you. Then you should, that should be the criteria to decide the tool to be used. Yes, Vishaka, I'll be sharing the links for the courses.
Asha ma'am. So can we take a break of 5 to 10 minutes and can we join because
sir, have
already...
you shared the link?
Couldn't hear you completely. Can you please come again, ma'am?
Asha ma'am, आपका आवाज नहीं
I'll share the links. If that was the question, yes, I'll share all the links. In the break,
Yes, this was only my question because you said that you will be sharing it. So the all students, at least students can take the benefits and teacher can pass on this to their students.
Yes, I'll be collecting those links and putting in a chart so that everybody can read.
Yeah, all of you, please note.
So we will take
Mulay sir, इससे पहले before the break we can have a one online click and then we can take a break. Pratiksha, are you there?
Not a problem, ma'am. हाँ चलेगा अभी अभी
Yes, yes,
अभी
I'm
ले
here.
लेते हैं.
May I request the participant to switch on their cameras? Sir, if possible, can you switch on your camera? Thank you, sir. So,
We will take a quick break and then we will immediately join because sir, we have to our vice chancellor will be there, will be present on valedictory. So we want this session to be concluded by 2 o'clock. So we will not spare much time on the break and we will join very quickly.
12:30 sharp, Mulay sir. It's at 12:30 sharp.
Uh,
20 minutes break, so they can be there with us till 2:30. Here,
exactly.
all of you, please have something. You can have something along with your tea, so you can with us till 2:30 because 2 o'clock even valedictory is there, and I think so that's a compulsory because during the valedictory your link, feedback form link will be shared.
Asha ma'am will be
I
having an
request everybody-
overall feedback also in valedictory, na? And another thing is their results will also be announced for all the
all the participants, the winners, and
all the
everything will be
competitions which we had
announced during
conducted.
so, during that.
Request everyone to be there as a part of valedictory. So now we have 20 minutes break. You all can not 20 minutes, 17 minutes now. So sharp 12:30 will begin so that we'll be able to finish in time and we can begin with the valedictory function in time. Thank you so much, everyone.
Santosh sir, 12:30 we will start a session.
Yes, sir.
Mulay
Yes, sir.
sir, मैं
I'm here
आपको
only.
1 minute है ना phone कर रही हूँ.
I'm there. I will be there. Okay.
Yeah, मैं आपको call कर रही हूँ.
हाँ.